One of the common interview questions is the differences between arrays and linked lists. You should be able to explain the differences in terms of required memory and time complexity of various operations. Arrays, or more accurately, static arrays, have a fixed size. So if we don't know ahead of time how many items we want to store in them, we should either use dynamic arrays or linked lists. Dynamic arrays grow by 50 or 100% of their size when they get full, and they may end up wasting memory. Linked lists, on the other hand, take only as much memory as they really need, nothing more. Having said that, linked lists take a bit of extra memory because each node should store the address of the next node in addition to a value. So if you know ahead of time roughly how many items you're going to store, you would better use an array, either static or dynamic, because arrays have a smaller footprint. For example, let's say you're going to store up to 100 items, but you're not sure how many items exactly. In that case, you may use a dynamic array with an initial capacity of 100. In Java, we can set the initial capacity when creating an ArrayList object. So these are the differences in terms of the space. But space is not everything. We should also optimize for performance. As you know, certain operations are fast in arrays but slow in linked lists. So as I always emphasize, you need to understand what problem you're trying to solve. Every problem has different solutions, and each solution has certain strengths and weaknesses. There is no such a thing as the perfect solution. You should always do trade-offs. And that's exactly what a good interviewer looks for. They want to see if you really understand a problem, can think of different solutions, explain the pros and cons of each, and pick the one that best works for a given scenario. Now let's compare these data structures in terms of their runtime complexity. Arrays shine when you need to look up an item by an index. In linked lists, we have to traverse until we find the item at a given index. Looking up an item by its value is an O of n in both these data structures because we have to iterate over all the items until we find the target. Inserting items in an array is an O of n because if the array gets full, we have to resize it and copy all the existing items to the new array. Now, this is not a big deal in an array of 100 items, but if you're dealing with an array of 1 million items, this is certainly going to be a big issue. Again, there is no such a thing as one size fits all. You need to understand the problem you're trying to solve. Inserting an item in a linked list can be either an O of 1 or O of n, depending on where we want to add this new item. Adding at the beginning or at the end is super fast because we simply have to change the links. But adding at a given index involves a lookup by index, which is an O of n operation. And finally, deleting items in an array is an O of n operation because we have to shift items to the left to fill the hole. With linked lists, if you want to delete an item from the beginning, we simply change the links. But if you want to remove it from the middle or the end, we have to traverse the list to find the previous node. In the next video, I will show you how we can optimize this using a different type of linked lists. So I will see you next.